One thing we do in algebra is take real life problems or word problems and turn them into algebra, turn them into letters. So here are some words that are used in different problems. So adding, the sum of, the total, more than, increased by. Subtraction words, less than or the difference means subtract. Of, product of, it's multiplication. Quotient, ratio of, out of, that's a big one. Out of is a division word. In adding and multiplication, those are commutative operations. And what that means is the order that you write things doesn't matter. For example, 2 plus 3 is the same thing as 3 plus 2. They're both 5. Same thing, multiplication. 2 times 3 is equal to 3 times 2. They're both 6. They're commutative. It doesn't matter, It doesn't matter what order you do them. But in subtraction and division, those are not commutative. For example, 2 minus 1 is not the same thing as 1 minus 2. So you have to be careful when you're making an expression out of subtraction and division of what order you put the terms in. Let's look at some examples. The sum of 9 and x. Sum means add, so the sum of 9 and x is 9 plus x. Or, since it's commutative, you could also do x plus 9. It would be the same thing. This is trickier. The difference of 5 and n. If you want to do the difference of 5 and n, you need to do 5 minus n. The order matters there. You can't do n minus 5. 7 out of 8. Out of means divide. 7 divided by 8, or 7/8 as a fraction. The total of n and 9. Total means add n plus 9 or 9 plus n. 6 less than n or n less than 6. Those are not the same thing. Subtraction is not commutative. 6 less than n. This is a tricky one. Let's think of this in numbers first. What if you said 6 less than 10? What is 6 less than 10? 4, right? What did you do to do that problem? You did 10 minus 6 and got 4. So 6 less than 10 really means 10 minus 6. So if you want to do 6 less than n, similarly you have to do n minus 6. So the 6 less than actually goes after the n minus 6. How about n less than 6? Well, that is 6 minus n. N less than means that you're going to subtract n from this number. That's a tricky one. 4 less than 7 times x. Remember, 4 less than means that we're going to subtract 4 at the end. So 7 times x, that would be 7x. Remember, when the 7 is right next to the x, multiplication is implied, 7 times x. And then 4 less than that would be minus 4. 7x minus 4. 12 less than the product of 2 and n. The product of 2 and n is 2n. 12 less than means at the end you subtract 12. I put these in again because they're tricky to me. The difference between x and y, that means x minus y. X less than y. The x less than comes after, so you do y minus x. Those are tricky. Go back to these in your notes if you're doing them in the homework and can't figure it out. 60% of a number. A couple of things in this one. First off, what does the of mean? Of means multiplication. Out of means divide. Of means multiplication. Next, a number. Since it's not defined as what number it is, we're going to use n for number, or we could use x, any variable. Third, 60%. Whenever we actually do a mathematical operation with a percentage, you have to change it to a decimal first, which we talked about last unit. 60% is 0.6. So 60% of a number will be 0.6 times n. 0.6 times n, or just 0.6n. 4% of a number. Again, 4% as a decimal, we have to move our decimal spot 2 places. 0.04 of is times, and a number, we'll choose n. So 4% of a number is 0.04 times n, or 0.04n. This one's tricky with the decimal in that percent. We have to do 2 places over. So that will be 0.005 of times a number. So 0.005 times n. Some algebraic applications require us to identify an unknown, give it a variable, and then express other unknowns in terms of that variable. Here's what I mean. Again, we're not really going to find any answers to this. We're just assigning variables, telling what the variables would be. Okay, example 1. A guitar string 10 foot long is cut into 2 pieces. Express the length of the shorter piece in terms of the longer piece. So your first thing to do is just make up a variable for the long piece. Maybe x. Or sometimes we might use L to stand for longer. Now the length of the shorter piece, what we're going to do is write it in terms of our other variable. So think about what we know. We know that the short piece and the long piece added up make 10. So I can write the length of the shorter piece as 10 minus the longer piece. Now, why didn't I just say, well, the long piece is x and the short piece is y, or L and S, or whatever? And the reason is, when we're solving equations, especially if we only have one equation, it's nice if there can be just one variable. If we have one variable in one equation, we're allowed to solve. Now we'll talk more about solving equations next chapter. For right now, we're just going to set these up. Example 2. 100 gallons of oil was, dumped, it should be, typo, into 2 containers. Use one variable to express the amount of oil poured into each container. So again, don't overthink this. All we're doing is assigning a variable to this problem. So gallons of oil in first container. Let's just make that x. So then in terms of x, how much oil is going to be in the second container? Well, if there's x gallons in the first container, and we know that there's 100 gallons total, if you just take 100 and subtract off however much x is, then that should be how much is in the second container. So we can use x to mean gallons of oil in the first container, and 100 minus x to mean how many gallons of gas were in the second container. Example 3. A square has a length that is 2 inches longer than the width. Use one variable to express the length and width of the rectangle. So width of the rectangle, it helps me if I have a picture of this. Okay, so the width. I know that the length, now I could put an L here, and then I'd have W for width and an L for length. But remember, I want both variables to be the same thing. Can I write this so that I just have one variable in it? If I have W here, I know that the length is 2 inches longer than the width. So I can name this piece width plus 2. So my 2 variables are W and W plus 2. I should say my 2 quantities are the variable W and then W plus 2. Again, we're not really doing a problem yet. We will set these up with equations next chapter and solve them so that we can find what W is.